Hello and welcome back. When Marconi made the first radio broadcast in 1895, he probably wasn't thinking about just how far it would go. The receiver in that day was just a little over a kilometer away, but ever since that faithful day, his signal has been traveling in space at the speed of light. It has traveled well over 125 light years from Earth. There are thought to be 76 stars within just the first 100 light years from Earth. Typically, each star has at least one planet orbiting it. Wouldn't it be something if some being heard that signal and was replying to it and it's on its way back? If that were true, as amateur radio operators, we could be galactic ambassadors and not even realize it. Are you ready to learn? Well, let's get started then. This is Lesson 3, Part 2 of my Amateur Radio Technician class license course covering the 2022 to 2026 question pool. My name is Gary Stevens, and I am your instructor. My call sign is Kilo Echo 2 Gulf Sierra. I hold an amateur extra license. I've been an amateur operator since 2001. An amateur extra since 2014, and teaching amateur radio for well over 15 years now. The T3 section covers radio wave propagation. On your exam, 3 questions are selected at random from this sub-element. There are 3 groups and a total of 34 questions. This video covers the second group, T3B, electromagnetic wave properties, wavelength versus frequency, nature and velocity of electromagnetic waves, relationship of wavelength and frequency, electromagnetic spectrum, and the definitions of UHF, VHF, and HF. Let's start by increasing our radio wave vocabulary. Amplitude, or height, is the distance between the middle line of a wave and its peaks. Frequency is the number of cycles per second. The period of a wave is the amount of time it takes for a wave to complete one wave cycle or wavelength. Wavelength is defined as the total distance covered to complete one wave. Harmonics are signals from a transmitter or oscillator occurring on whole number multiples of 2, 3, 4, etc. of the desired operating frequency. We need to know that the relationship between the electric and magnetic fields of an electromagnetic wave is that there are right angles. In this slide, we can see the magnetic field in blue and the electric field in red. They are identical in wavelength and direction, but are at right angles with respect to each other. The exam question is, what is the relationship between the electric and magnetic fields of an electromagnetic wave? A, they travel at different speeds. B, they are in parallel. C, they revolve in opposite directions. Or D, they are at right angles. The correct answer is D, they are at right angles. We should understand that the orientation of an electric field is the property of a radio wave that defines its polarization. In this slide, we can see that the electric field is vertical. So therefore, the polarization in this case is vertical. The test question is, what property of a radio wave defines its polarization? A, the orientation of the electric field. B, the orientation of the magnetic field. C, the ratio of the energy in the magnetic field to the energy of the electric field. D, the ratio of the velocity of the wavelength. Which of course the answer is A, the orientation of the electric field. It is essential to know that the 2 components of a radio wave are the electric and magnetic fields. This image is a reminder of the 2 components of the radio wave and their relationship to each other. Again, the radio wave consists of an electric and magnetic field. The related question is, what are the 2 components of a radio wave? A, impedance and reactance. B, voltage and current. C, electric and magnetic fields. D, ionizing and non-ionizing radiation. The slide showed us that the answer is C, electric and magnetic fields. You need to know that the speed of light is the velocity of a radio wave traveling through free space. Free space means the absence of matter, much like outer space. Our exam question looks like this. What is the velocity of a radio wave traveling through free space? A, speed of light. B, speed of sound. C, speed inversely proportional to its wavelength. Or D, the speed that increases as the frequency increases. The answer is A, speed of light. You should understand that the relationship between wavelength and frequency is that wavelength gets shorter as frequency increases. This slide shows that the frequency of the top wave is higher than the one on the bottom. It also illustrates that the wavelength of the lower frequency is longer than that of the higher frequency. Our test question is, what is the relationship between wavelength and frequency? A, wavelength gets longer as frequency increases. B, wavelength gets shorter as frequency increases. C, wavelength and frequency are unrelated. Or D, wavelength and frequency increase as the path length increases. The correct answer is B, wavelength gets shorter as frequency increases. It is essential to know that the formula for converting frequency to approximate wavelength in meters is wavelength in meters equals 300 divided by frequency in megahertz. This slide shows the wavelength as the distance a wave travels in one cycle. Its symbol is the 11th character in the Greek alphabet, lambda. Well, the formula of the wavelength is the speed of light, c, divided by frequency, f. The math can be simplified by dividing 300 by the frequency in megahertz. On the exam, you might see this question. What is the formula for converting frequency to approximate wavelength in meters? A, wavelength in meters equal frequency in hertz multiplied by 300. B, wavelength in meters equal frequency in hertz divided by 300. C, wavelength in meters equals frequency in megahertz divided by 300. Or D, wavelength in meters equals 300 divided by the frequency in megahertz. We know the answer to be D. Wavelength in meters equals 300 divided by the frequency in megahertz. Know that in addition to frequency, the approximate wavelength in meters is used to identify amateur radio bands. Here once again is the colorful ARRL band chart. Have you downloaded a copy yet? If not, just search for it with your favorite browser. Upon examination, you will notice the approximate wavelength next to the frequency in parentheses. Try using the formula we just learned on a few. For example, 300 divided by 144 megahertz is 2.083 meters, or 2 meters for short. So the band would be 2 meters. Our test question reads, in addition to frequency, which of the following is used to identify amateur radio bands? A, the approximate wavelength in meters. B, traditional letter or number designators. C, channel numbers. D, all of these choices are correct. Now you know that the correct answer is A, the approximate wavelength in meters. You need to memorize this. The 30 megahertz to 300 megahertz frequency range is referred to as VHF. Here we can see a simplified version of a radio spectrum. Note that the VHF segment of the spectrum ranges from 30 megahertz to 300 megahertz. In addition to the amateur radio waves, you will find television broadcasts and FM radio in the VHF or very high frequency range. The exam question will be this. What frequency range is referred to as VHF? A, 300 kilohertz to 300 kilohertz. B, 30 megahertz to 300 megahertz. C, 30 kilohertz to 3000 kilohertz. Or D, 300 megahertz to 3000 megahertz. You should have picked B, 30 megahertz to 300 megahertz. Another thing to remember is that the 300 to 3000 megahertz frequency range is referred to as UHF. This slide shows the UHF or ultra high frequency range is between 300 megahertz and 3 gigahertz. 3 gigahertz is the same as 3000 megahertz for those of you who are metric system challenged. Also, in the UHF range, we can find such services as UHF TV and mobile telephones. On the exam, the question will be, what frequency range is referred to as UHF? A, 30 to 300 kilohertz, B, 30 to 300 megahertz, C, 300 to 3000 kilohertz, or D, 300 to 3000 megahertz. We know that the answer is D, 300 to 3000 megahertz. We must also understand that the 3 to 30 megahertz frequency range is referred to as HF. This slide shows that the HF, or high frequency range, goes from 3 megahertz to 30 megahertz. The HF range is sometimes referred to as shortwave, even though you can see that there are much shorter waves. The exam question looks something like this. What frequency range is referred to as HF? A, 300 to 3000 megahertz, B, 30 to 300 megahertz, C, 3 to 30 megahertz, or D, 300 to 3000 kilohertz. The correct answer is C, 3 to 30 megahertz. Once again, make sure that you know that 300 million meters per second is the approximate velocity of a radio wave in free space. Once again, make sure that you know that 300 million meters per second is the approximate velocity of radio waves in free space. If you're abducted, don't forget to tell your new alien friends that they must observe our speed limits for light and radio waves, which we know is 300 million meters per second. For the exam, you might see this question. What is the approximate velocity of a radio wave in free space? A, 150,000 meters per second, B, 300 million meters per second, C, 300 million miles per hour, or D, 150,000 miles per hour. We know that the answer is B, 300 million meters per second. We are at the end of Lesson 3, Part 2. Have you noticed that radio waves are measured in the metric system, as well as the measurement of light? By the end of this course, we will be even more familiar with the metric system. I hope that you're finding this information easy to learn and to follow. However, if you do not get some of these principles, just watch the video again and learn from your mistakes. Remember that fictional character from Star Wars named Yoda? Remember what he said? The greatest teacher failure is. Until next time, my friends, never stop learning.